Hello, so this video will start chapter 4, which is on covalent compound, and we will go over section 4.1. So first, let's briefly remind you what covalent compounds are. There are two types of compound. There are the ionic compound and then the covalent compound. And so covalent bonds results from the sharing of electrons between two nonmetals or between a metalloid and a metal. Remember that ionic compounds were made of a metal and nonmetals, and the metal would transfer electrons to the nonmetal, and so you would create cations and anions, and there was a strong electrostatic attraction between them. Now we are moving away from that. Covalent bonds are not due to a transfer of electron, it's due to a sharing. Electrons are shared between two nonmetals or metalloids and nonmetals. So there is no metals involved in this type of compound. So here there is hydrogen. Hydrogen, atomic number 1, is in group 1A. So even though it's in group 1A, in the group for alkali metal, this is not a metal. Hydrogen is a non-metal. And so hydrogen has only one electron in its electron cloud. And so that's the simplest atom. And as a non-metal, it likes to bind with itself and make a diatomic molecule. Remember, diatomic means it's made of two atoms of the same kind. And so molecules are what we call a discrete group of atoms held together by covalent bonds. So molecules is really what we use to call a covalent compound. It's not how you should call an ionic compound. Ionic compounds are typically salts. And when we talk about a molecule, it means we have only nonmetals that share electrons between them. So a covalent bond is a two-electron bond in which the bonding atoms share valence electrons. So hydrogen is an exception because hydrogen needs only two electrons to be happy. Hydrogen tries to be like helium. The next noble gas after hydrogen, it's helium. You go from the left, top left of the periodic table directly to the top right corner, and you see helium there in group 8A. Helium is an halogen, but it's an exception among the noble gases. It needs only two electrons, and it has only two electrons, helium, atomic number 2. And so hydrogen wants to be like helium, and it will be satisfied with a duet of electrons, just two electrons. So by putting two hydrogen atoms together, and if they each share their one valence electron, then they will be surrounded, each of them, by two electrons. And that will satisfy their, their need. So you have to imagine that as the drawing shows it here, electron clouds are, clouds, so they don't have a real envelope, even though we give them an outer bond. They really don't have an envelope per se, and so they can overlap. The electron clouds can overlap with each other. And that's what happens when electrons share electron. Their electron clouds overlap. And in the zone where they overlap, they can share electrons. And so you see here how the two electron clouds are making one big cloud where the two electrons are shared in the middle. And so that's how hydrogen would make the diatomic molecule H2. H2 is the hydrogen molecule as you find it in nature. So some vocabulary here that you need to learn. Unshared electron pairs are called non-bonded electron pairs or lone pairs. And I will use lone pairs. I will not use non-bonded pairs, but you have to know that when I refer to lone pairs, it means two electrons that are not bonded, that are not shared between atoms. So they belong to one atom in particular. So here, for example, we have hydrogen bonding with fluorine. Hydrogen, atomic number 1, has only one valence electron. Fluorine from group 7A, an halogen with 7 valence electrons. So you see 7 dots around F. And so when they bind together, so they are two nonmetals, so they bind together to make a covalent bond. And so hydrogen needs only another electron to be happy. And fluorine needs also only one more electron to have 8 around it. Because that's the goal for all atoms, it's to get an octet of valence electron around them. So fluorine, by sharing its electron, and hydrogen, by sharing its electron, they both reach so a duet for hydrogen and an octet for fluorine. And that's how they get stable. So HF is more stable than the atoms by themselves. And so you can see that around F, there are 3 lone pairs, 3 pairs of atoms that are not bonded. So a lone pair is represented by 2 dots, and a bond is represented by a line. The line between HF represents 2 electrons that are shared between H and F. And so a lone pair will be 2 dots because they are not shared. They belong to F in this example. So atoms share electrons to attain the electronic configuration of the noble gas closest to them in the periodic table. And as we said, hydrogen will share 2 electrons to be like helium, and these 2 are exceptions. Otherwise, all other elements, all other main group elements share electrons until they reach an octet of electron in their outer shell. Again, an octet means 8 valence electrons. So that's the goal of all other atoms. By doing this, they will all have an electron configuration that resemble the electron configuration of noble gases. So before we try doing Lewis structures, I want you to look at common bonding patterns for the main nonmetals. And so hydrogen, we've already seen that it needs only one more electron. So by doing one single bond, and it will have no lone pairs. So hydrogen will be typically making only a single bond and will never have lone pair around it. So that's an exception. Otherwise, so carbon, being from group 4A, has 4 valence electrons. And so it needs 4 more electrons to get 8 around it. So that's why the predicted number of bonds is 8 minus the number of valence electrons. And here, 8 minus 4 is 4 bonds for carbon. So carbon typically makes 4 bonds, and it will have 0 lone pairs around it. Nitrogen in group 5A, so if you do 8 minus 5 is 3. So hydrogen will typically make 3 bonds. So 3 bonds, that's 6 electrons around it. And then it will have a lone pair of 2 electrons. So 6 plus 2 is going to be 8 around it. So nitrogen, by making 3 bonds and having a lone pair, will have 8 electrons around it. Oxygen in group 6A has 6 valence electrons. It needs 2 more electrons to get 8 around it. So oxygen will make typically 2 bonds. By doing 2 bonds, it has 4 valence electrons plus the 4 bonds plus the 4 electrons from the 2 lone pairs. That will be 8 valence electrons around oxygen. So oxygen typically makes 2 bonds and has 2 lone pairs around it. The halogens, remember, are atoms from group 7a, 7 valence electrons. And so to get 8 around them, they need only 1 more electron. So by sharing an electron with another atom, they will get that 1 more electron they need. And so they will typically make only 1 single bond and will have 3 lone pairs around them. So you can see that another way to see that is to see that the number of bonds plus the numbers of lone pairs is equal to 4. If you look at carbon, 4 bonds, 0 lone pair, that's 4. Nitrogen, 3 bonds, 1 lone pair, it's 4. Oxygen, 2 bonds, 2 lone pairs, it's 4. And the halogens, 1 bond, 3 lone pairs, it's 4. Right, it's because we talk about pairs, so that's why from 8 you divide by 2 and it's 4, right? So what you want to remember is that they all want to have an octet around them, and for this they will do bonds with other nonmetals.